Hi friends, welcome back to my channel Testing Mini Bytes. I'm your friend Amunad Shaktivel, and in this video, we're gonna see about more lambda expressions, right? In the previous videos, we have understood what is a lambda expression, how to write a basic lambda expression, and we also understood what is a functional interface, right? If you haven't watched those videos, I would highly suggest or recommend you to watch those videos before watching this, right? So because that forms the basis for this particular lecture, right? So we're gonna see how we can write more lambda expression. We have written only a simple basic lambda, but in this video we're going to write a lot of different lambdas using different method signatures. We're going to learn about that in detail. We'll also understand what is the lambda syntax. If you feel little difficult, maybe you can remember the syntax for the initial time being, and then you can build your lambdas based upon this particular syntax, right? We'll also see how Eclipse can help us to convert anonymous inner class implementation of your functional interface to a lambda expression. With just one shortcut key, you can convert anonymous inner class implementation to one lambda expression. That's going to be really, really cool, right? So if you are not understanding what I'm speaking now, that's completely all right. Okay, by the end of this video, you should be in a position to understand that. We're gonna try out different method signatures, right? So if there is a method that accepts one parameter but does not return anything, right? You can imagine, right? So if there is a method which just accepts one parameter, you can imagine on your mind how that method signature will look like. When I mean signature, how the method skeleton will look like, right? What if a method accepts two parameters and does not return anything? So I want to write a lambda expression for all these combinations. So we're going to see about that in detail. At the end, we're also going to see about how the method name in this vertical functional interface is not relevant anymore, right? So this is very, very important because we're going to use a lot of interfaces built in Java in the coming classes, so that you need to understand what is the problem with the current multi the in the we are creating a lot of multiple functional interfaces for our use, right? If you want to use a functional interface, you need to create a functional interface, you need to provide different method signatures, right? So you're almost creating 10 to 15 functional interfaces for your use. That's something that's not needed. What if Java guys can provide you something already available, right? We want to see about that in detail. If you're not understanding what it is now, that's okay. We want to see that about in detail. Good. So without wasting much time, let me head to the Eclipse workspace, right? This is a project that we have been working so far. And if you notice, we have an interface that is a functional interface. We call an interface as functional interface if it is only having one abstract method or unimplemented method. It can have any number of default or static methods, that doesn't matter, right? So for time being, this looks like a nice to me because I've already explained about functional interface. Let me remove this for now. We can also keep it. That doesn't going to make any difference. But for more readability and clear understanding, I'm just removing all that, and I'll only have one particular abstract method, right? There is a way what we used to follow. If you want to provide an implementation for this, in the conventional way, we create a class, we implement this particular interface, we provide the implementation, right? That's how we do it before 1.8. If you don't want to use a anonymous inner type class implementation, so this is your conventional way. So you create an object for this particular class file, right? And then you call that particular print method using that particular object reference, right? So this is your normal way of doing it. In the anonymous inner type way, we didn't have to create specifically a class like this with a name. We can create a class on a fly, like your anonymous inner class. Again, guys, I have explained this in detail in the previous class. So previous lectures, please do watch that if you don't understand what is an anonymous inner class. So quickly, so there is a method wrapped inside a curly braces, which is a class, right? There is a method that is wrapped inside a curly brace, that's a class, right? So here we don't have a name for this particular class. So this is anonymous class. This class is also present inside another class. So we call it as anonymous inner class, right? We can also provide an implementation using anonymous inner class, and we can call this using object one.print, right? In the lambda way, right, we have seen three rules: that your parameter of the abstract method, parameter of your abstract method is null. So we are not passing any parameters here. We are also not passing any parameters here. So the return type of the abstract method is void, and we are also not returning anything. So there is a match. And then at the end, it also needs to be a functional interface, which means it should have only one abstract method. Okay, if that matches, if these three condition matches, we can write it in using a lambda, right? So if you notice, this is the lambda expression we have wrote. So there is a method signature, that is your this is your method signature, right? And then lambda operator, and then your implementation, right? So this is what we have done, and it's all working absolutely fine, right? So now if you are facing some issues, hey Amudan, it's little tricky for me to understand how to write a lambda, right? So in that case, maybe you should know how to write your anonymous inner class. We have derived anonymous inner class. So let me remove this whole stuff again, right? Let me build it again, everything from the scratch. So just type I new I printable. Okay, so if you notice, it's populating me with the Eclipse ID is populating with me this suggestion. Okay, let's put this, and now we have created an anonymous inner class on the file with just one single click. So you can provide your implementation here. Okay, my implementation is this is anonymous inner class, something like this. Okay, now this is fine, but I want to convert this into a lambda, right? So maybe I can create a local variable now. For that, you can use a shortcut Control+1 and then click on assign statement to a new local variable. Yeah, you can name it as object2 or whatever you want, right? So now I have created an anonymous implementation. So I can call this using obj.print, right? From this, if you notice, my left hand side is this, then my right hand side also will be this, right? And also, if you notice, the public void print, right? This is already known to me. Okay, my Java compiler is now smart, so you can understand all this information. So I'm going to remove all this unwanted code, and then I'm going to remove it from here. While I remove, I am removing a curly brace, so I'm also removing this curly brace, okay, to match it. So I have removed a lot of code. So I want to tell Java compiler that I have removed unnecessary code. I want to write a program in a functional way, so I'm adding a lambda operator in between. This is our anonymous inner class implementation using instead of writing an anonymous inner class implementation, we have written a lambda here. And also, if you notice, if there is only one statement, you can also remove this curly brace, right? And then if there are two semicolons, you can remove one and you can write it in the same line. This is how we derived this, right? This is how we derived this. Maybe we already have a object2, so I can rename it as obj1. So this is how we have arrived at this lambda, but this is a little tricky and sometimes I may forget. So let me do a Control Z on all of these. Okay. And then you just press somewhere here and then put Control+1. Okay. Once you do this, it's telling convert to lambda expression, Control+1, convert to lambda expression, and you got your answer. Okay. Again, if you go here, it will also show you, if you hover your mouse over this, it can tell you this is how your lambda expression gonna look like. Do you want this way? Yes, I want that way. Just click on that. So again, I can change this to obj.print. Okay, now we have also understood how we can create a lambda expression and then work with it. So let me go back. Okay, I want a basic lambda expression. So I'll remove this whole code. I'll remove one thing. Okay, from this I can arrive at my basic skeleton, right? You have your this thing, and then you have a lambda operator, and then you have curly braces. So this is what my basic syntax is. Okay, so you have something like this. Okay, you have two parentheses where you want to define your parameters, and then a lambda operator, and then curly brace. Inside curly brace, you can write a lot of statement. If there is only one statement, then you can also remove the curly brace, but there is no harm in using curly brace. So this is your basic skeleton. So this is your basic skeleton, guys. So once you can understand, we can write more lambda expression like this, right? So for now, I'll remove these things, and then I'll keep only this, right? So that we can play around by creating a lot of method signatures and how we can write a respective lambda for them. So that's what we're going to do. So we have already seen about this condition. We're going to see about these two conditions in this particular video. Good. So the basic lambda, right? So let's say I now do some changes. Okay, I say I want to pass some integer to this method. Okay, this is this is unnecessarily causing me issues, so maybe I can make it as abstract so that I don't have to provide the implementation. I'll remove this. Okay, good, so that it won't throw any error. Now this is throwing me an error because one of the condition is your parameter of the abstract method, okay, should match with this. But here, if you notice that it's not accepting any parameter. So what I'm doing, I'm accepting a parameter now. Okay, so you are accepting a parameter, but you are not doing anything. Maybe I can add something like this. Whatever the parameter I got, I'll print that. Okay, right? That's what I'm doing. You can name it as A, you can name it as B, you can name it as I, you can name it as E, whatever you want. Okay, you can name it whatever you want. And whenever you're calling this method, if you're calling a method that is accepting a parameter, you need to pass a parameter. So I'm passing 6 as an integer. Okay, let's try to run the test now and see what's happening. So it is working. So if you're, so we have written a lambda that accepts a parameter, integer parameter, and prints it, right? But it does not return anything. So it can also accept a string. So if you want to change this, let's say I want to change this to string. Okay. Now if you save it, it is again throw the error telling you want to pass string. Okay. And then you can put it as yes. So that's more meaningful. Okay. And then here also yes, string yes. And then you can pass a string. Okay. Whatever the string you pass, I'm gonna print it. That's it. As simple as that. But we're gonna use a functional programming way, right? That's what very important. So if you notice, hey Amudan, you told a lot of things the Java compiler can understand. Why can't see it has understood public, void, print everything? Why cannot it understand that the input parameter is string? Yes, it can also understand that. So you can also remove it. It's not needed. So you can basically understand that you are passing a string from this particular method signature. So your method signature tells Java compiler you how we are going to use your lambda expression. So you can name it as string, you can name it as message, you can name it as name, whatever the variable name that you want to give, you can give here, right? That's absolutely fine, right? So this is really cool, right? So now we have seen about these two things. Method accepts one parameter and does not return anything. So we have seen about integer parameter and string parameter. What if can accept two parameters? Okay, yes, let's try it out. Suppose let's say I'm changing my method signature to string a comma string b. Now, okay, string a comma string b. I'm gonna do a concatenation and then I'm going to print it. So that's what I'm gonna do. If you pass me two strings, okay, if you pass me two strings, I'm gonna concat them and I'm gonna print it. Okay, this is how I'm writing my lambda. Okay, so maybe you can also give a space in between. Okay, yeah, you can also write like this. So now it gives a space and it's printing it, right? Again, from this interface, it can intercept these two information, can infer these two parameters or string. So basically you can remove them. You don't have to pass them. Okay. Yeah. Will it work? Yes, it's absolutely will work. Okay. So that's the beauty about writing lambda. So I fail to, denote you guys one thing when it is just one parameter, right? When it is just one parameter, okay, you can write like this. Okay. You're writing like this, right? So you can also, okay, you don't have to mention this braces, this curly brackets. You don't have to mention if the number of parameters to your lambda is just one, you don't have to mention that as well. So it's as easy as that. So you can infer a lot of information. That's why Java 8 compilers are very smart, right? So we have done these things, right? So what else we can have in a method? So we can also have a method that does not accept any parameter, but it returns something, right? You can imagine a method skeleton, right? All right. So it does not accept anything, but it can return something. So maybe it will return string. So let's try. Okay. So I'm gonna cut this out because it's not accepting anything, but it can return something out of it. Okay. Now I am getting confused how to write this. More than it's again confusing for me. Okay. If it is confusing, again do a printable, provide the anonymous inner class implementation. So now you get an idea how this method will look like. So this method, if someone is calling this method, I want to return them hello. That's what I want to do. So if someone is calling this, I want to return them hello. So maybe press Control and 1. See, now you're getting an idea. So this is returning you string. Okay, this is still confusing for me because there is no braces, something like that. Okay, then we'll take it from very basics. So my left hand side is equal to my right hand side, so I don't have to tell this. I also can understand, my Java compiler can understand information till here. So I'm removing a curly brace. Okay, I'm removing this, I'm removing one curly brace, I'm removing this. Now if there is only one statement, right, this is your basic lambda that you can write, right? So if you don't have to pass anything, but if you call me, I'm gonna return you and hello. You can write everything in one line. But if you notice, if there is only one statement, okay, you don't even have to mention the curly brace. Okay, you can remove it. If you're just returning that, okay, then Java compiler can understand if there is only one string, one statement, and you are returning something, then it can understand you are returning something, or you don't have to even mention this. Okay, so if someone is calling you, you're gonna return them and hello, right? It's as simple as that, guys. You can understand a lot of information from this, right? If you haven't understood, please rewind and watch it again so that you can understand. So because why, so you need to ask a question, right? You can ask a question, why if there is a specific criteria for one statement, guys? If there are a lot of statements, suppose you write return one, and then you write some logic, and then you are telling a return two. Okay, in that time, Java compiler doesn't know what to do. There are a lot of statements it has to understood, and compile it cannot understand. But if there is one simple statement, then you don't have to mention your curly brace, right? So if you remove this closing brace, you can also remove this. And then anyway, I know you are going to return this because you have to satisfy the condition of returning a string, right? If you are implementing, if you are providing implementation for this method, so I can also understand this, you don't have to mention. Okay, I removed everything. That's what, right? This is what is suggested by your Eclipse IDE as well. So if you go over here, I replace this to hello. Okay, press control and one, convert to lambda expression. This is what it suggested, right? So let me check. Okay, I don't have to pass anything to this method. Okay, I don't have to pass anything. But if I call this method, okay, if I call this method, it's definitely gonna say hello to me. But see, I'm not printing it, so it will return me hello. So if I want to see it, maybe I need to put a sysout statement and then call it, right? It's as simple as that. Right now, this is printing me hello, right? So this is very, very easy, guys. So what is the next method signature we're going to deal about? What if a method that accepts one parameter and returns something, right? So let's say I pass a string. Okay, let me pass a string. Whatever the string that I pass, okay, it has to do something, and then it has to return me another string. Maybe it can return me a lower case of it. Okay, then how can I change it? Okay, maybe I'll put a string. If I pass a string, you need to return me whatever that I come, you need to return me to lower case. See, again, I can infer this information, you don't have to put it there. Again, I can infer this information, so I don't need that. So you just pass Amudan or everything in caps. Okay, you call it again. Okay, it's gonna return you everything in small letter. So basically it can infer a lot of information. So basically when you're seeing code like yes, people normally prefer yes because they're gonna represent string. So yeah, some use e, some use e, some use f, some use s. It's up to you. You can give any name you want, right? So it's absolutely doesn't matter, right? So we have also seen about a different signature. What if there is a method that accepts one parameter and returns a boolean? So what if it accepts a string and then it returns a boolean? Okay, let's say it accepts a string and then it returns a boolean. Maybe I just want to check whether the string is not null, okay, or whether the string is not empty or something like that. Then okay, now again my basic lambda skeleton is, you need to have this, you need to have this, you need to have the body. This is your basic skeleton. Now if you notice, it is accepting a string. Okay, so we can mention string a, but it needs to do some operation and it needs to return me a boolean. So what I can tell, I can write some conditions. So return maybe a dot length. When the a dot length is greater than 0, then I want to return true, something like that, right? Yeah, so this is your basic skeleton that we have written. Again, this is information is already known. You can remove it. If there is only one parameter, you can remove it. Again, if there is only one block, you can remove this, you can remove this. You can also understand you are returning, so you don't have to mention this. Your lambda becomes much neat and clean now. So if you pass something like this, okay, it will definitely return you true. If you pass something like this, now this will return you false, right? So basically you can have your method signature with different possible combinations, right? That's what I, at the end of the day, you can write lambda for any method signatures. So what if, why I'm repeating all these things again, guys, you'll understand in the next video. But for now, you need to be in a position to write a lambda expression, whatever may be the method signature. The method signature can be anything, but you should be in a position to write a lambda expression. Please practice this, guys. It's gonna really help you in test automation. I'm gonna speak about that in the upcoming videos, but you will definitely love it, right? Okay, what is the irrelevancy of this method name in functional interface? Let's say, you see, instead of this print name, okay, I can use any name. So let's say I'm using some get name like get. Okay, the only difference that I'm gonna make is the way I'm gonna call it is using the get method. The name can be anything, it doesn't matter, it will absolutely work fine. Okay, so it can be anything, guys, so it'll absolutely work fine. Okay, so the method name is completely irrelevant. You can give any method name, but people prefer giving some meaningful name. If you're going to print something, give a name of print method, right? So that's a basic usage of a method, right? So your method name given least preference. So it can be anything, but make it more readable. If you are going to implement your own functional interface, provide some lambda expression implementation to that, definitely have some meaningful name. So that's what I want to tell. So here, instead of this, I can also name it as print and then revert to my old name, right? It doesn't matter. At the end, what is the problem with creating multi-function? Suppose, let's say I want to create a lot of functional interfaces, right? So for this method signature, I created one. For another method signature, let's say I want to create one more thing. Okay, that is that's again an interface. Let's name it as scanner interface, something like this. Okay, this scanner interface, it's having abstract. It accepts something. Okay, maybe it accepts some document or some integers for now, and let's name it as scan, and then this is the functional interface. Let me annotate a functional interface. This is okay. If I want to provide the implementation, I can provide using lambda. Okay, let me go here. So you can provide an implementation. So scanner interface. Okay, let's say it as scan equal to new scanner interface, and I'm coming from anonymous inner type. Okay, let's say it's returning me 0. That's okay. Control 1. Okay, Control 1 convert to lambda. So you can provide your own implementation. That doesn't matter. But the problem is, if you want to use 10 different method signature, you need to create 10 different interfaces yourself. That is gonna be really tricky, because if this is one particular method signature, right? If I want to change this to integer, then you need to create another interface that gonna work, because your parameter type also matters, right? If it is a int, that is one method. If it is a string, that is one method. So you cannot create 100 interfaces if you want to provide implementation for 100 different method signatures. That is practically impossible. That's why Java has some inbuilt functional interfaces that what we're gonna see about that in the next particular video. But if you liked my video so far, please share and subscribe with your friends, guys. Please share it with your friends, right? I'm sure you're gonna learn a lot of new things in the coming sessions. So until then, I'll say a goodbye. Okay, you all have a very good day. Stay safe, stay inside, guys. That's very important in this pandemic situation. I see you in another great video. Tata, bye bye.